Okay, good afternoon. Today we'll be doing roots and zeros and learning about a rule called Descartes' rule of signs, and I'll explain what that is soon. So, ready to start? Yay, math? Yay, math. Okay, good, thank you. I like it. All right. Please write the following polynomial. All right. There's a French descent mathematician, philosopher, scientist named Renee Descartes. All right, the S's are silent. He's considered the father of modern philosophy. That's his title. He came up with the phrase "I think, therefore I am." Translated "Cogito ergo sum."
His name's Renee?
Yeah.
He's French.
Renee Descartes.
Cogito
Right.
ergo sum. Cogito.
Cogito ergo sum. Is it je or cogito?
I'm pretty sure it's cogito.
Okay, I've heard differently, but I could be wrong. You know, je pense, donc je suis. I think, therefore I am. That's because it's French. All right, so that's his thing. And besides these wonderful philosophical notions that he's taught, he's came up with a very interesting and useful tactic. We look at a polynomial. How many solutions does this polynomial have? Three. Three solutions. We said that the solutions match the degree of the polynomial, the highest power. So now what if I were to ask you, okay, how many of those solutions are, let's say, positive? How many solutions are negative? Or how many solutions are imaginary? We want to really know by looking at it, okay? But this Descartes character came up with a way to know, all right? So let's find out how. So let's make a little chart. Plus will imply the positive solutions, okay? You put a little line. We'll need a little room down here. Negative will imply the negative solutions, so that's negative real, like -1, -2. And this column we'll call imaginary.
So it doesn't really exist, but we like to think.
Right, imaginary solutions. It'll work inside the polynomial, but it's not a real number. Let's slide an f of x in here. Is that in the frame there? F of x?
What's the color?
Okay, it says f of x. Okay. All right, good. Here's how to do it. All we do, first step, is we count the number of times the sign changes from term to term within this polynomial. So let's talk about it. X cubed is naturally positive. There's a 1 out here. So we go from positive to -4. Did the sign change?
Yeah.
Okay, call that one sign change. Then we go from negative to positive. Did the sign change?
Yes.
Yeah, so 2 total sign changes. Then we went from positive to negative. Did the sign change?
Yes.
3. So that's 3 total sign changes. 3 goes here. Okay. Next, for the negatives, what we do is we apply f of negative x. Meaning, in place of x, here, here, and here, we're going to put negative x. Okay. So if we put negative x here, and we did negative x cubed, what would this result be? Would it be x cubed or negative x?
Negative.
It would be negative, wouldn't it?
Yeah.
Because
Yeah.
negative x times negative x times negative x is negative x, and here it comes, negative x cubed. What if we put a negative x here? Would this change or not?
It would.
Yeah. No.
Okay.
It would
If
just
I-
turn out -4x squared.
It would still be negative 4x squared. Let's explain really quick. If you put negative x here, it would be negative x squared.
Oh, positive.
What's negative x squared? Positive x squared. It would look exactly like this. So it won't change. So we'll put -4x squared. If you put negative x here, would this be plus 6x or minus 6x?
Minus 6x.
Very good. Minus 6x, and naturally the 4 remains. Now we count sign changes again. Negative to negative. Did the sign change? Did the sign change?
No.
Did the sign change?
No.
0.
So why did the 4 not change?
Because it's a constant and there's no x's.
Okay.
It's only when x becomes negative. So here there's an x, so you change it here. Here it doesn't change. Here it changes. And the 4 is a constant. Here's a little, here's a question for you, for your future problems. When you do f of negative x, which kinds of powers always change and which kinds of powers always stay the same? But yeah, finish that.
Even changes I mean, even stays, odd change.
Right. The even ones stay the same because when you square something or you do something to the 4, the negative cancels itself. But the odd ones change because negative times negative times negative here, okay, I'm just conducting. 3 negatives here will make this change its sign. This one too. This is an odd power. Is that clear? Any questions about that? All right, good. So there we go. There you have it. So if there's 3 total solutions, and that we say 3 of them are positive and none are negative, how many imaginary must there be?
0.
0 also. Right.
Oh.
0 also. Okay. So far, considering Descartes' rule of signs, this one has 3 positive solutions and no negative solutions and no imaginary solutions. Questions so far? It's pretty cool. All right, so we all know that already. There is a part 2 to this. Okay? Here's the part 2. We're going to call this
Part 2.
like possibility 1. So it's possible that this is the system here. It's possible that there's 3 solutions, 0, 0. The second possibility is down here. Pos 2. And here's how pos 2 works. This is the hardest part. So if you get this, you're solid. You take one, either this number or this number, whichever applies. In this case, we'll take the 3. And you decrease it by 2. That's it. Until you get to either 0 and you stop. Or if you get to like -1, you can't do that. So we're going to decrease this by 2. And that will make this 1. So let's talk about a few possibilities. What if this had been a 2? What would this number be? 0. So 0 solutions. What if this had been a 1? Could we decrease it by 2? No, we can't have -1 solutions. This is the number of solutions. Right? What if this had been a 4?
We'd have 2.
We'd take it down to 2, and then we take that one to option 3, 0. If this was 4, possibility 2 would be 2, and then the next possibility would be 0. That's all. And once you have like zeros in here, you do it for these 2 rows basically. Once you have 0, you can't take it down anymore, so you leave it. All right. So the 3 we can take down to 1. 0, can we take it down?
No.
No, we can't, so we replicate it. And now, if there are 3 total solutions, one of those is positive, none are negative, how many must there be remaining?
2.
There you go.
Wait, so you can't, what do you call it, for negative, but you can for imaginary?
No, you can only for the ones that you are allowed to take down to. So we couldn't reduce this by 2. If another problem had this as 2 or something, then we would reduce that.
And then for imaginary, you can because it's imaginary.
Yeah, the imaginary actually works off these 2. All right? The imaginary is like what's left. You know what I mean?
Yeah.
Okay. Question anymore? So there we go. This is the possibility. Either it's 3 solutions positive or 1 positive and 2 imaginary. So let's go ahead and try to solve this. Let's try to find its solutions. How do we get to imaginary? Because there's 3 solutions. 1 is positive. We know none are negative, so there must be 2 remaining imaginary. So before the calculator days, this is what they did. They would create this chart and would say, all right, so what are some possible solutions? What would you think would be one possible solution? How about like -4?
Yeah, 0, -4. Oh, well, that's...
Could -4 be a solution? Or -3? Or -2?
No.
Or -1?
It'd have to be positive.
It would have to be positive. How do we know the solution has to be positive?
Because it says up there.
Because there's no negativos. See? Yeah, feeling the burn of mid-year. So, follow my lead. Here's how to basically do it. I'm going to try positives. I'm going to try positives. I won't try negatives. That's the whole idea.
Should move it down a little bit.
What?
Love you too.
Because the love spot makes
Love spots. How about it looks like an eye? There we go. Okay, 1, -4, 6, -4. All right, let's see if 1 is a solution. Ready, go. 1, a 1, a Negative 3.
Either.
Negative 3. 3. 3.
Negative 1.
Negative 1. Is this a solution?
No.
No, it doesn't divide evenly. 1, no solution. So, then you don't have to erase it. I'm going to. We're going to do it with 2 now. Try it with 2. All right, here it comes. So 2 is coming in. 1, negative 4, 6, negative 4. Notice Descartes' rule allows us to know that there's no negative solutions. Impossible in both options. That's the important component. What? This one works? How do you know? You did it in your head?
I did it on paper.
You did it on your paper? Wow, you guys mix it up. Negative 2. Negative 4. 2. 4. Yes. So that's 0. So the resulting equation basically is x squared goes here. 2x plus 2. Okay. So this can be written as x, so 2 is a solution, so x minus 2. And the resulting equation, x squared minus 2x plus 2. Any questions about that? This we know is a solution, 2 is a solution, so we synthetically divide it. We have a resulting equation as the solution there. And then we solve this. Yes?
So you always have to guess the first solution. So
Okay, now, good question.
Is that how we're gonna have to do it?
Or you pop it in the calculator, all right, and you see where the solutions are in the calculator based on the graph.
But like, are we always going to be able to do that?
So far with me, yes, I'll let that go. Yeah, I'll let that go. Because I mean, it's like, if you can do this and understand it, I'm cool. And you know that there's no negative solutions. But then again, if the calculator would show you that the solution is 2, and then you have to synthetically divide, you have to get this, now you have to solve this yourself. Let's solve this ourselves. Ourselves, I guess it's kind of a misnomer, because our self implies 1. Ourselves, like many of ones. I am a philosopher too. Equals 0. All right, completing the square. You know how to do it. Tell me what to do. Minus.
Wait, no factoring?
Can it be factored?
Yeah.
Plus 2.
No.
Positive.
Can it be factored?
No.
So subtract 2 on both sides.
Yeah.
X squared minus 2x equals negative 2. What do we add to both sides now?
2. No. I don't remember.
Negative 2 over 2.
Oh, it's half of
Half
b.
of b squared, right? So what's half of b is negative 1. Squared is 1. So we add 1 to both sides. And now we can write this as something like that.
X minus
And what's negative 2 plus 1? Get that out of the way. Negative 1. All right, this is x what?
minus 1.
X minus 1, right? Remember we talked about how this is half of b squared, and this is half of b,
Right.
right? Half of b squared, half of b. Half of b is negative 1. Now what do we do to both sides?
Square
You
root.
guys are pros at this now. Let's finish it out. Okay.
X minus 1.
X minus 1 equals, what's the square root of negative 1?
I root.
I root 1.
I root 1. What is root 1?
1.
So do we need to write it?
Just write
Just
this.
I.
I.
So
You know,
minus I.
plus or minus I. You know that the square root of negative 1 is I. You know that. So that's plus or minus I. Add 1 to both sides. We have x equals 1 plus or minus I. So there are your 2 additional solutions. Solution 1, x equals 2. Solutions 2 and 3, x equals 1 plus or minus I. That's it.
So what is the second possibility?
What do you mean? Oh, so it's the second possibility, correct. So it's the second possibility. Very good. See, it fits.
How did we get the first possibility?
We got the 3 by counting sign changes.
Oh.
All right, that's the heart of it. You count the changes in sign.
And that gives you your positive solutions?
Right, and then you make x negative, and that'll give you your negative solutions. So let's do that for the next one. So I'm going to take this off. You can finish writing that if you'd like. Let's keep these. Okay. Now for the next one, it's a big one. I'm just going to ask you possible solutions. F of x equals 4. Okay, I'm going to take it.
Oh my god.
Okay, now.
What is that?
Now, all I'm going to ask you, it's a polynomial with 5 solutions. All I'm going to ask you is, what are the possible solutions? That's all. Are they positive, negative, or imaginary? So all I'm going to ask you is the chart in this one. All right? Later on, you're going to do this. This will be the end of the chapter. One problem, like on the test, will be, what are the solutions? So you'll need everything. You'll need this. Probably your calculator to help you synthetically divide, and on and on. But first, let's focus on the chart. All right, we got this?
Yeah.
Yeah? Okay, count the sign changes in your mind, and then I'm going to say 3, 2, 1, and say what it is all together. So count the sign changes in your mind, wait. Okay, 3, 2, 1.
3.
4.
4.
4. Okay, pause to neg. 1, 2, 3, 4. 4. All right, now we're going to make x negative. And we agreed that the only ones that will change will be the odd powers, right? So this is what I like to do to help myself out. X to the 5th, will it become positive or negative?
Negative.
Negative. Minus 6x to the 4th, stay. I'm going to write negative again. X to the 3rd, will this change?
No.
Negative. It stays
Negative.
It stays
Well,
negative.
well, hold on. This becomes negative, right?
Plus.
So
Times the positive.
Times
Because
this.
negative is positive.
This will result in positive.
Right.
Oh yeah.
This becomes negative,
Yeah.
combines with that. In other words, if you want to think about it, the odd powers are the ones that change sign. Again, the odd powers are the one that change sign. So this to the 3rd changes this sign. This to the 2nd, does this sign change?
Nope.
No. This to the power of 1, does this sign change?
Yes. 'Cause it's,
Yes.
Yeah.
it's negative. You said it's odd, so it changes.
Yes, it's odd. X to the 1.
Plus.
And then this remains plus. Number of sign changes?
2.
1.
1. Negative to negative did not change. This changed,
Oh, right.
and
So
then it
that's it.
remains. So now we have 1. All right, 5 total solutions, 4 and 1. How many imaginary?
0.
0. Okay, now what is option 2? What goes here?
2.
2. 2, right. We take this down by 2. So this goes 2. Can this be taken down?
No.
No, so it remains 1.
Wait, I don't understand that.
Okay,
Because remember you subtract by
we
2.
subtract each possibility by
Oh.
2 if possible.
Okay.
And now if we take this down by 2, that'll be negative 1. We
Okay.
can't have negative 1 solutions. You know, it's like, how many solutions are there? 5. How many solutions are there? Negative 1. It doesn't work, all right? So there's 1, so if there's 5 total,
2.
2 and 1, there must be 2 remaining. That's it. Okay, last one here, coming.
There's one more.
Yeah,
Yeah.
but you can bring it down.
Because we
Bring
can
it down
still
to
bring it
0.
down. Yeah. This one's hefty. Possibility 3,
0.
0,
1.
1.
4.
That's it.
Only a
That's it. 0 positive solutions, remaining 1 negative solution. What?
How do you figure out the imaginary?
Because there's 5 total,
So it's
so the 4 remaining solutions must be imaginary. Right? That's all. That's it. You did it. You learned it. All right. Wasn't so bad, huh?
Is that the first half?
Yeah, that's the first time. So now you can look at this and say to yourself, when you're solving more complex equations in the future, you're solving more complex equations in the future, you need this. Hold on, stay with us. You need this to help you out, so you know what the possibilities are. Because what if, by some chance, you got three positive solutions? You know it's impossible. Yeah, you know it's wrong. Okay, good job. All right, thank you, Yay Math.
Amen.
Yeah. Bye.
2, 3, 2, 1.